Okay, so one of the cool things about functions is that they are going to kind of work the same way no matter what type of function you're using. So we have already talked about translations and transformations in this class for other functions, right? So this first slide here, once it comes up, just has some review of those functions. So translations, it's easy to get the word transformation and translation mixed up. Transformation can be any kind of change to the graph. Translations right here, those are your slides. It doesn't change the shape of the graph, it slides it up, down, left, or right. Okay? So if I have f of x equals x squared plus 3, it is the blank function that is shifted blank by blank. So what type of function are we dealing with here for this problem? It is not exponential. If it were exponential, Granger, it would look like this, 2 to the x power. That would be exponential. So the exponent has to be the variable for it to be exponential. This one has x squared. That's a quadratic. So this is a quadratic function, and it is shifted. Now, I realize you could say like up or down here, but let's go with vertically or horizontally. Which one's this one going to be? This is vertical by positive 3, which means it's going up 3, right? So if we put a number out here on the end of a function, it moves it up or down, and it goes in the direction you think it should. All right, what type of function do we have here on 2? That is cubic. And is this translation going to be vertical or horizontal? Horizontal. Okay, by what factor there?
Very positive 5.
Positive 5. I'm almost glad you said negative 5 because it looks like it, but anything on the inside of the parentheses is backwards, right? So these rules still apply to trig functions. They work just the same on trig functions. There's just going to be a little bit of vocabulary that's going to be a little bit different whenever we're dealing with trig functions. But the general principle still applies. So let's look at this. Vertical shifts affect the midline of a sinusoidal function. So the other day, whenever we were doing our jigsaw activity, you should have found that that midline was that line that would go through the middle of the graph, right? Halfway between the maximums and the minimums. What was the midline of just regular old sine of x? What was it? Good. What variable equals 0? X or y?
No, y.
It's y. It's y equals 0, but that is the x-axis. Right, y equals 0 is your x-axis. So a vertical shift is going to shift that midline up or down that much, right? Because if you slide the whole graph up or down, that midline goes with it, right? So what would the midline of f of x equals sine x plus 1 be?
What?
Let's give an equation for it. Y equals 1. Very good. All right, just moves it up 1. Okay, so I have given, this right here is like the way that AP is going to present sign transformations. You got all these A, B, C, and D are all integers right here of some sort. Actually, not integers. They're constants. They could be decimals if you wanted. If I had this and A, B, C, and D were all constant values, what would the midline of this equation be? Okay. What's, huh?
Plus D.
Plus D. Y equals positive D. Right there. So this number right here is the only one that's going to change the midline. Moving it up and down is the only thing that changes the midline. So that is the number that gives you your midline every time. So whenever you have different equations, it's really easy to find the midline. That's one students usually have no trouble with at all. All right, let's continue on. Let's talk about a horizontal shift. Okay, horizontal shifts affect the position of the function, but they don't change amplitude, period, or midline. They affect where it's at, but they don't actually change anything about the key features of the graph. This is kind of what would tell you, like, if you're, sine, we could just slide it over and it would match cosine, right? So that just shifts it, but it doesn't really change any of the features of the graph. But a lot of times whenever we talk about horizontal shifts with trig stuff, we also sometimes call them phase shifts. And if you think about that word phase used in real life, like the phases of the moon, or it's, the phases of the moon kind of go around circularly. They just, you got new moon, first quarter, full moon, third quarter, new moon. It just keeps going. I may have said that wrong. That might have been the term I got wrong there, but it just keeps on going. The phase is like where you're at in that. So this shifts where that's at, and that's why it's called that. So if you have a really simple function, it's just the horizontal shift. So if we look at f of x equals sine x plus 5, what is the phase shift for that function? This particular one we would not give as an equation because it's not a line on this one, but you're right about that -5. So it would be horizontal shift of -5, or you could just say it went left 5. Probably more likely, like answer choices are going to say horizontal shift of -5, but it just means it goes to the left 5. Okay. All right. So if we look at C, what's the phase shift for this crazy equation?
Would that be x equals -c?
Again, we won't say x equals, but we'll just say horizontal shift of -c. Now do notice right here, that's b is in like an extra set of parentheses, right? So if we have a value for b, we have to have the theta plus c factored out right there. It has to be in that extra set of parentheses. We're going to see that in a minute, but we're not going to worry about it too much right now. Okay. All right. Let's move on. All right, let's review some dilation. So these aren't trig functions. These are just regular old functions that we have already seen prior to now. And we're going to talk about dilations. Remember, dilations are your stretches. You stretch it out vertically, you squish it in vertically. You stretch it out horizontally, you squish it in horizontally. Here for 7, I've got f of x equals 3 times the absolute value of x. What type of function do we have here? What are these bars right here called? Absolute value. This is just our absolute value function. So the absolute value function is, so you could use the word, so like right here, I could use the word dilated, or I could use compress or expand. Let's use compress or expand because it's more specific. We could use the word dilated for the first blank on all of these, and it would still be okay. But because dilations can be either stretches or shrinks. But let's go with expand or compress. So if I have a number 3 out here, is that going to be an expansion or compression? Expansion. So it is expanded. Is it vertically or horizontally? Vertically. By what factor?
3.
3. Okay. 8 is also an absolute value. Okay. Expansion or compression this time? Compression. Vertically or horizontally? Vertically. What's the factor? 0.25. Okay, your vertical is on the outside of the bars in this case, and it does what you think it'll do. Big numbers make it bigger, expand. Small numbers make it smaller, compress. The factor is just the number. Okay. On the inside, it's a little bit different. So this here, what type of equation would we call that? Just a square root. So the square root function is, all right, will the 1/2 expand or compress? It compress. Oh, sorry. You're tricking me, Lucas. It expands. Everything's backwards on the inside, right? So expands or expanded vertically or horizontally? Horizontally. By what factor? 2. Because you got to do 1 over 1/2. It flips it, right? That's going to be 1 times 2 over 1, which is just 2. So it's not, everything on the inside is more complicated, right? Everything on the inside is backwards. So you got to do 1 over the number, not just the number itself. Okay? And then for this last one, we got, again, a square root. And are we expanding or compressing? Compress. Vertical or horizontal? Horizontal. What's my factor? 1/4. There. Okay, so that is all review, right? That's all stuff that we've already looked at in this class, and really before this class you looked at it as well. That is all review. Let's apply this to trig functions. Again, it is going to be the same principle, it's just the vocabulary is a little bit different because of the way we identify parts of a trig function. So if I have vertical dilation, that means I stretch it up taller or I squish it down shorter. What part of the function is that going to affect? That's your amplitude, right? Because it's either stretching it up, making those waves go really tall, or it's squishing it down and making the waves really small, right? But it doesn't stretch out anything about the period or the midline. It's just the amplitude that's affected. So if I have 5 sine x, my amplitude would be 5. So if I have f of theta equals a sine b theta plus c plus d, what is my amplitude there?
A.
It is A? Almost. I'm going to throw a technicality here on you. What if A is negative? If A is negative, like if I got a -3 right there, do the 3 and the negative do the same thing? What's a negative do when we put it out there? Negative on the outside. What's that going to do to a graph? It flips it, right? So I'm going to put some absolute value bars around that A. Because the negative is going to be a flip. It doesn't change the amplitude. Flipping it doesn't change the amplitude. So the amplitude of function is always positive. So if there is a negative out there, you don't include it.
Where do we get the negative?
I was just saying what if there was a negative, because A could, like, you might see an equation, like, for example, we might have y equals -6 sine x plus 2. Something like that. And so my amplitude for that would just be 6. It wouldn't be -6. because the negative flips the graph. The 6 is the only part that's your amplitude. Because this A right here, it could be any number, so it could be a negative one. Okay. So amplitude is always positive. Don't get tricked on that and put a negative for it. Otherwise, amplitude is very easy to find. It's just a number multiplied out front. Most students do great on that and don't have any trouble with it. Let's keep going. All right. Horizontal dilations, this is usually what is kind of the trickiest about these, because if we're squishing in the graph or stretching out the graph, what are we doing? What is it going to affect for the function? It's the period of the graph, right? The period is how long it takes for it to repeat. So if we squish the graph in this way, it doesn't take as long to repeat, right? It's like an accordion, really. You're squishing it in and out like an accordion. This is going to be a little bit different. What is the period of just regular y equals sine x? What's the period of that? We looked at this yesterday. How long did it take your sine graph to repeat? 2 pi. Which goes with our unit circle, right? Because that graph of sine is the values from the unit circle. So once you've gone all the way around the circle once, which is 2 pi, it starts to repeat itself over and over again. So the period of just the regular y equals sine x is 2 pi. Now, if I put a 3 on the inside, let's talk about the expansion compression we got there. It's on the inside, so it's horizontally. So horizontally. Is it a compression or an expansion? It's on the inside, which makes it horizontal. It's compression, because big numbers bigger than 1, make things smaller on the inside, right? So horizontal compression by what factor? 1/3, right? So what we're going to see here is that we have horizontal compression by 1/3, so the period used to be 2 pi. Now, the period of f of x is going to be 1/3 of 2 pi, which is going to just be 2 pi divided by 3. Okay? Does that sort of make sense? We're compressing it by a factor of 1/3. It makes it 1/3 smaller, so it just makes the period 1/3 of what it was. So, for 14, in general, do we know whether this is an expansion or compression if we just have a b there? We don't know what b is, right? We don't know if it's bigger than 1 or smaller than 1. So we don't know if this is a compression or expansion. So let's just call it horizontal dilation, because we can use that word generally. We don't have to specify for that. So a horizontal dilation by, what's my factor? My number here is b. It's not going to be b because like right here it wasn't 3. What was it? 1/3. Right? So here it's going to be, it's weird, 1/b. Right? Because we don't have a number there. So whatever b is, we're going to do 1/that. So that means the period of f of theta would be 1/b of 2 pi, which the easier way to write that is just 2 pi divided by b. So if you need to know the period of a function, it's normally 2 pi. You're just going to divide it by whatever the b is for that. Okay, everybody okay here? Okay, so let's generalize a little bit here and make sure we sort of combine it all together. If I have this equation that I've used several times, what is my amplitude?
A.
It is A, almost. I'm going to add something else to it.
Oh,
Let's put some absolute value bars on a technicality, right? If that's negative, we got to make it positive. Okay? Period. Nope. D's used for something else.
midline.
What would be midline?
D.
D is midline, yeah. So for our midline, if we skip down there, y equals D is our midline. In my opinion, those two right there, easiest to find, right? This number right here is just always your amplitude, absolute value of it anyway. And then this number right here, that's always your midline. And there's not much work that has to go on there. Our period for sine would normally be 2 pi. But we have a horizontal compression or expansion by a factor of 1 over b, right? So it's going to be 2 pi divided by b for your period. And then what is our phase shift?
Minus C.
Minus c. Oh, I did not do part of the last question. The last question asked me for 2 things, and I didn't do 2 things. What did it ask for?
Frequency.
It also asked me for frequency. So yesterday, this may have been the one you may have understood a little better, a little worse. The period is how long it takes something to repeat. The frequency is how many times it repeats in a given unit, right? I really liked, in fact, let me look at the second period. I really liked the picture that you guys used. The one that third period used was not as good for this. My period right here is 1/4, right? So I've got one whole cycle is 1/4, 1/4, 1/4, 1/4. So in one entire unit, the frequency would be 4 because I got 4 full cycles there. So frequency and period are reciprocals of each other. So over here, if my period is 2 pi over b, frequency would be b divided by 2 pi. Which, if you go back and fix that where I skipped over here, right here, the period for this one was 2 pi over 3. So what would the frequency be?
3 over 2 pi.
3 over 2 pi. And this is basically just the formula here. Your frequency here is b over 2 pi. So if you're asked for frequency, usually I just flip whatever I have. I usually think in terms of period. I do that first, and if I need frequency, you're just flipping whatever you had for your period. There. All right. So this slide right here is sort of like, if you know this, then you should be able to do these problems pretty easily. If you know how to find all of this from the slide, you should know how to do these problems pretty easily. So let's look at a few. Or especially the straightforward ones anyway. And these are pretty straightforward. So if I look at 15, let's see, Emma, what is my amplitude? It's 3. And I'm going to do the easier ones first. Granger, what's my midline? Good. And for a midline, we want to do y equals 4. since it is a line, it's a horizontal line, you want to do y equals so that's the equation. Okay? All right, those two I think are a little bit easier. Now, this does not have parentheses, but if it did, they would be right here. Do we have anything going on inside of the parentheses? So we have no horizontal shifts. The only thing that you're allowed to put none for is the phase shift. This is none, and that's the only one you can ever say none for. The rest of them, you have to have amplitude, period, and midline. So these must have answers no matter what. And really frequency too, because if you have a period, you're going to have frequency there. So what would the period of this graph be? What is the period of regular sine x? 2 pi. Have we stretched it out or squished it in any to change that? We have not. There's no horizontal dilations here, so it just stays 2 pi. So if you don't have any numbers on the inside with your x, then it just stays 2 pi. Okay?
Pi 2.
Not pi 2.
2 pi over 1.
We got to flip the fraction. So this is 2 pi over 1.
1 over 2 pi.
So we got 1 over 2 pi here for our frequency. Okay? So the only one you're allowed to have a none for is your phase shift. Everything else is always going to have an answer. Does that make sense? All right. Tyler, what's my amplitude on number 16? Okay. Let's see. Lucas, what do you think the period of that is?
There's stuff going on the insides of the 2 pi.
Or tell me, what does that minus 3 do on the inside?
It like moves it to the right 3.
Okay. That is our phase shift. So we go to the right 3. Is there anything else happening there that would change the period of the graph? There is not. So it stays 2 pi, which means frequency is going to be 1 over 2 pi. What's the midline for this?
0.
It's 0. So midline you always have to have an answer for. You can't say none, but we could put a plus 0 out here on the end and it wouldn't change anything. So it's 0. Because it's not been shifted up or down. Y equals 0. The x-axis is that midline, right? Okay. We're good here. All right. So let's keep going. Okay. Now, when we had our equation, it looked like this. F of theta equals a sine. Oh, I also forgot to tell you, it doesn't matter whether these are sine or cosine. All these same rules still apply. I use sine in my equation, but you can use sine or cosine. The only thing that changes is what your starting graph looks like. But all the transformations, amplitude, period, midline, all of those things are going to stay the same. If you actually graph it, they'll look a little different, sine versus cosine. But amplitude, period, phase shift, all of those will stay the same. So the formula I gave you looked like this. B parentheses theta plus C, close the parentheses again, plus D. Is that what it looks like here on this equation? It does not. We don't have those double parentheses here. In order to use the formulas that we were coming up with here, the strategies we would have to use, I have to factor out whatever number is there in front of my x, right? So let's rewrite this. It's going to be 2 sine of, if I factor out a 2, I will have 2 times x plus what goes over here? 2. Okay, so if we have a problem that looks like number 17, we want to factor out that 2 so that it looks like this before we start trying to answer the question. So, let's see. Solana, what's the amplitude on that one? Very good. Granger, what would our period of that graph be? Not 1 over C for that. Our period normally for sine is 2 pi, right? So it is 2 pi over the b value. What's our b value in this problem? 2. I realize I've made a bad problem where all the values are 2. We are looking at this 2 right here, not the other 2's. So we would do 2 pi divided by 2. But what is 2 pi divided by 2? 2's cancel. It is just pi for our period. What's happened there is it's half, like you're doing the compression by 1/2. So it takes half of 2 pi. All right, let's see. Lexi, what kind of phase shift have we got? Left 2. Very good. If you look at the original equation, you're going to say left 4. That's why we got to factor it out. You'll get that part wrong if you don't do that factoring right there. Let's see. Alyssa, what's the midline for that one? Very good. We don't have any numbers over here on the end, so it's like it's got a +0 there. Lucas, what's my frequency? 1 over pi. Very good. Just the reciprocal of your period. Good here? Okay. Lucas, what's our amplitude on number 18?
Oh, we have to factor it out, don't we?
You do need to factor this out, but it doesn't affect amplitude.
Oh, it'll be 2 pi over 3?
That is our period. What's our amplitude?
Oh. It'll be 0.
It's 1. So there's we don't have a number here out front. That's where we find our amplitude. If there's not a number there, it's going to be 1. Because if we do 0 times something, it goes away, right? But if we do 1 times cosine, it's the same. So we'll use 1 right there. And Lucas is correct. We do need to factor out that 3, or we're not going to get the right answer for our phase shift. So we're going to do 3 times x minus 2 plus 4. So, Maddie, what would the phase shift be? Right 2. Perfect. Okay. Let's see. Alyssa, what's the midline? Good. And we're going to put y equals 4 because we want it to be the equation of a line for that. And Granger, what's the frequency going to be? Close. We would be doing 1 over the period, right? So our period here was pi, so we did 1 over pi. So we're doing 1 over 2 pi over 3. So let me write my 3. But when we do that, what does it do to the fraction? It just flips it, because 1 times dividing fraction is easy as pi. Flip the second and multiply. That's going to flip that second fraction. You're just multiplying by 1, so that doesn't change it. So we're going to get 3 over 2 pi. So your period and your frequency are reciprocals of each other. You flip the fraction. Up here, pi wasn't a fraction, so it was like pi over 1, and we flipped it and got 1 over pi. Okay, questions there? All right, now let's do this sort of backwards. Now we've got all our information. We've got to write our equation. So you do this the exact same whether it says sine or cosine, except for you just use sine or cosine, right? But all the other pieces are the same. I really should have made that second one cosine, but I didn't. We're using that f of theta equals a sine of b theta plus c plus d. And so you can use a theta or an x. It doesn't matter which variable you use, or anything else, alphas, betas, z's, whatever you want to use. So if my amplitude is 4, that is just my a value. That goes here, right? And then I would have sine of, and then I'm gonna wait on that inside stuff, and what do I have on, if my midline is 0, what do I have on the end?
Nothing.
Nothing. If you need to put something there just for your sanity, you could put a plus 0, but it's unnecessary, right? So, my period is 2 pi. Sine is usually supposed to have a period of 2 pi. So, do we have a b value right there? We do not. Or if we do, it's just 1, right? If it doesn't change anything. But then we'd have theta. We do have a phase shift of -2. So what would we have here on the inside? Plus 2. Now, probably answer choice is going to look like this for sine of theta plus 2. They won't write that 1 there. They won't put the plus 0 on the end. Okay. All right, let's do the next one. We've got, let's just use a x just to show you we can. You can use whatever variable you want. Let's do f of x equals, amplitude is 0.5, so that goes out here. And then we got b parentheses. I'm just going to do this right now. I'm going to put b parentheses theta plus c. We're going to worry about that in a minute. All right. What's my midline? 7, so I'm going to have a plus 7 out here on the end. So now let's work on, let's do phase shift. I'm going to do period last because I think it's the hardest. If my phase shift is 1, that affects my C value. What should that C value be? It's going to be -1. So let's make that -1 right here. And I said I was going to use an X, and then I threw a theta right there. Let's use an X right there. Now, the B is kind of the trickiest one to find, right? To find period, we do 2 pi divided by the B value, right? So 2 pi, so a lot of times what students will do is they'll take whatever the period is and they'll put it there for their B, and that is wrong. Because the period is not just B, the period is 2 pi divided by B. So if we take 2 pi divided by B, we should get whatever the period is, which is pi. What does B have to be for us to get? It should be 2, right? So that B right there should be 2. Sometimes this is a hard number to find. This one is pretty easy because you can see the 2's need to cancel. If it is a hard number, here's an option for you. You can cross multiply. B times pi would equal 2 pi. And then you would divide by your pi. And B would equal 2. Not really necessary because it's pretty easy to see what B should be here, but sometimes it's harder for that. So that would be our equation. Okay, questions there? Okay, let's skip and do, well, we kind of need to do both of these. All right, I'm going to move them pretty fast. All right, so f of theta. Is everybody okay if I go ahead and do this real quick? 5 out here. Sine of, I'm going to leave that stuff on the inside blank. I'm going to put a -4 over here. Everybody good getting those numbers? Okay, and then I'm going to have b times theta. If I have a phase shift of 6 pi, what do I need inside of these parentheses here? -6 pi, right? Now we've got to deal with b. Remember, 3 pi over 5 does not just go there as our b. 2 pi divided by b gives us our period. That's our formula for our period, right? What does the period equal for this one? 3 pi over 5. This one's harder to see what's happening, right? Like the last one, Lucas could just tell me it needed to be 2 off the top of his head. Do you guys know what it needs to be off the top of your head here? I do not. So, cross multiply. That is going to give you 3 pi times b equals 10 pi. And then what would I need to do? Divide by what? That 3 pi. Because you're trying to get that b by itself. So divide by 3 pi. The pi's cancel. B is 10/3. So that is what would go right here. Okay, we're going to do this last one. I've got f of x equals, amplitude is 60. That goes right here. I'm going to leave the stuff on the inside alone for a second. And then I'm going to put a plus 150 out here on the end for our midline. All right, if I have a phase shift of -10, what needs to go on the most inside parentheses? Plus 10. Okay, and then I've got that b value right there, right? So 80 does not go there. I know that 2 pi divided by 80, I'm sorry, 2 pi divided by b, sorry. I don't know what I'm doing. 2 pi divided by b is supposed to equal 80. All right, so if I want to solve that for b, I'm going to multiply both sides by b. So 2 pi equals 80 b. I'm going to divide by 80. And so 2 and 80 reduces, so I'll get pi over 40, 1 pi over 40 for my b. So right here in this equation, that b right there is going to be pi over 40. And that would be our equation there. So, nothing is going to be due tomorrow. However, I would probably, if I were you, first of all, I'd study for the test tomorrow, maybe by doing that warm-up again, or the quiz, not test. And then tomorrow we're going to have 2 assignments. We're going to have a Delta Math and a worksheet that we're going to do. If I were you, I would go try to do a little bit of the Delta Math tonight. Don't worry about getting the whole thing done, but try to do a few of the problems for that. Because we will have the whole class period to work tomorrow other than that first 10 minutes or so we're going to use for our quiz, 15 maybe. But it is probably going to be a little too much to get done. Now, you're always welcome. If you're like, my weekend is free, I would just rather do it then. Do nothing tonight, that's fine. Or if you're like, I refuse to do anything till it's the very last minute, do nothing tonight. But I would do a little bit of it. Maybe do the first section or two on Delta Math and be ready for that. Thank you, guys.